We have the equation 5x squared plus 1 times y prime minus 20xy equals 10x. Transforming the equation into standard form, we have y prime minus 20xy over 5x squared plus 1 equals 10x over 5x squared plus 1. Then, finding the integrating factor of this equation, we have v equals e to the negative integral of 20x over 5x squared plus 1 dx. Then, letting u equals 5x squared plus 1, we have du equals 10x dx. Then du over 10 equals x dx. Then substituting it to the integrating factor, we have v equals e to the negative integral of 2 du over u. Then we have e to the negative 2 ln 5x squared plus 1. Then we have v equals 5x squared plus 1 to the negative 2. Then we have here dx times y times the integrating factor 5x squared plus 1 to the negative 2 equals 10x over 5x squared plus 1 times the integrating factor 5x squared plus 1 to the negative 2. Then integrating both sides, we have here y times 5x squared plus 1 to the negative 2 equals the integral of 10x over 5x squared plus 1 cubed dx. Then we have here y times 5x squared plus 1 to the negative 2 equals integral of du over u cubed. We get this by letting u 5x squared plus 1. Then we have here du equals 10x dx. Then du over 10 equals x dx. Then integrating du over u cubed, we have y times 5x squared plus 1 to the negative 2 equals negative u to the negative 2 over 2 plus c. Then substituting the value of u, which is 5x squared plus 1, we have y times 5x squared plus 1 to the negative 2 equals negative 5x squared negative 1 times 5x squared plus 1 to the negative 2 over 2 plus c. Then dividing both sides by 5x squared plus 1 to the negative 2, we have y equals negative 1/2 plus c times 5x squared plus 1 squared. We have here the equation x times y prime minus y equals square root of x squared minus y squared. Then we have to replace y prime by dy over dx. So we have x times dy over dx equals square root of x squared minus y squared plus y. Then multiplying both sides by dx, we have x times dy equals square root of x squared minus y squared plus y times dx. Then to check if this equation really is homogeneous, we have to replace the variable x by xt and the variable y by yt. Then we have xt times dy equals square root of xt squared minus yt squared plus yt times dx. Then factoring out t. Then as we can observe, t from the left side and on the right side are both in the first degree. Therefore, they are equal and this equation is homogeneous. Then we have here x times dy equals square root of x squared minus y squared plus y times dx. Then substituting y equals ux, we have here getting the derivative, we have dy equals u dx plus x du. Then substituting it from the equation, we have x times u dx plus x du equals square root of x squared minus ux squared plus ux times dx. Then we have x times u dx plus x du equals square root of x squared times 1 minus u squared plus ux times dx. Then cancelling out x from the equation, we're now left with u dx plus x du equals square root of 1 minus u squared dx plus u dx. And cancelling out u dx from the equation, we're now left with x du equals square root of 1 minus u squared dx. Then cross multiply, we have du over square root of 1 minus u squared equals dx over x. Then integrating both sides of the equation, we have sine inverse u equals ln x plus c. Then substituting u equals y over x, we have sine inverse y over x equals ln x plus c. Then we have y equals x sine ln x plus cx.